Hello friends and welcome back. In this week's video I will be picking up where I left off last week by designing and building a switch panel along with building some servo mounting brackets and installing them. I'm also going to make some decisions about mounting the DCC command station and the throttle. If you are following the series, I'd like to say a big thank you for your continued support. Let's get into this week's episode. In order to house my toggle switches, I need a switch panel. I spent some time sketching out some ideas and writing notes of what I wanted out of the switch panel, as you can see in the intro clip. I like to have a rough idea of what I want, and then I let function create the form of the final product. After sketching the basic shape that I wanted, I used IntelliCAD, which is very similar to AutoCAD, to draw up the 2D components that would make up the switch panel. I used the dimensions of the toggle switches to guide my design. The control panel needs to hold 8 toggle switches as well as the Roku command station. The control panel is going to be secured to the layout, and I really want it to be a special feature of this layout. I'd like to have a track plan with numbered points corresponding to the toggle switches. When it comes to laser cutting and fabrication, I always find it best to test a design in 3D first. This saves material being wasted and silly mistakes can be avoided. Designing in 2D for a 3D result is always tricky, no matter how long you've been doing it, so I try not to miss this step. Once I was happy that all the components worked the way they were supposed to in the 3D model, I moved on to laser cutting. I'm using 3mm laser cutter friendly MDF here. I find the MDF incredibly easy to work with, and it's far more robust than what one might imagine. I'm using MDF for the switchboard housing, but I had other ideas for the actual panel. With all the parts cut out, I started to assemble the switchboard housing. I'm using cyanoacrylate glue with an activator to bond the components together. This provides a very good bond in an incredibly fast time. The stuff is highly toxic and unforgiving, so if you do decide to work with it, ventilation and protective gear is a must. One has to be certain that components are properly aligned before spraying the activator. I used to use wood glue many years ago, but I found that keeping joints aligned with the flexible MDF was tricky. This is my current go-to for bonding. The faceplate that the toggle switches will be mounted to needs to be attached to the housing separately, and it's essential for it to be removable so that I can work on wiring and troubleshoot if I do have problems at a later stage. I'm using M4 machine screws to secure the plate in place, so I made provision for the nuts to be secured into the mounting plate. I cut the holes about 0.2mm smaller so that the nuts will have a firm fit, ensuring they don't fall out over time. Once all the nuts have been secured in place, add some glue to the edges and secure the mounting plate to the rest of the housing. With the mounting plate in place, I now have a secure mounting point for the faceplate of the switchboard. Hopefully this layout will see some good action over the years, so it's important to make sure that this part is solid. With the activator sprayed on all the joints, the CA glue sets instantly, and we can now see this design taking shape. No matter how many times I do this, I always get so excited when I see something that I imagined, then sketched out and then drew on the PC become a real prototype. It just never gets old for me, and these little victories are so motivational during these very long projects. In order to keep the layout compact and neat, I decided to house the Roku command station in the switchboard. It's not a very big unit, so it actually fits in here very well. The command station fits in the corner of the housing, and a hole has been cut on the left hand side in order to see the status LEDs on the side of the unit. The tether cable for the lock mouse will be connected to the command station and run out the access hole on the right hand side of the switchboard. The lock mouse will remain connected to the other end of the tether, and I will build up a throttle stand for it at a later stage. The next step is to secure the switchboard housing to the rest of the layout. I used the holes in the housing to mark out the necessary points that I need to drill out to mount the unit to the side of the layout. I used my cordless drill to drill out all 4 of the mounting holes. To be honest with you, I hadn't really thought about cutting out a rectangular hole in the side of the layout when I designed the back of the switchboard, so a spade bit had to do for now. I secured the switchboard in place with M4 machine screws and nuts. The 4 screws are more than sufficient to keep everything held together in place firmly. With everything secure, I did a test fit to see how the command station would fit with wiring. You are able to see where the track wires connect to the command station, as well as where the tether cable feeds out the side of the housing. Now the command station does fit well, but as you can see here, it will most definitely move around inside the housing if it isn't secured in place. To rectify this, I made a mounting bracket to hold the command station in place. I cut a small square out of MDF and I press fitted a nut into it. This will be glued onto the floor of the housing. I also made a Z-shaped clamp that will be tightened down with an M4 machine screw, and this should clamp the station down securely. I glued the nut to the floor of the housing and screwed the Z bracket in place, resulting in a really good grip on the command station. I'm pretty happy with how this method turned out. The power unit for this command station is huge and heavy. The only place that I felt it could be permanently placed was under the layout. So I flipped everything over and screwed this behemoth in place with 4 wide thread drywall screws. This ensured that it had a strong and secure hold. As I mentioned before, I really wanted this switch panel to be a feature of the layout. It's the first thing that you're going to see when you operate this layout, and it's a pretty central feature to the layout because all the operations take place from these toggle switches on the switch panel. I decided I'd use acrylic sheets for the main material, and I cut all the parts out of grey and white sheets that I had left over from some previous jobs. My day job involves a lot of design, and as any designer will tell you, the way to design is by using layers. You can see that my entire concept relies on the layers fitting together like a puzzle. By using layers of colored acrylic, I avoided having to paint components. Every component has a crisp edge and the final product looks great. I did consider using LEDs to indicate the direction that each point was in, but I decided that it was a little bit too much work than what I was planning for this particular project. I instead decided to paint the first layer of the panel with red and green acrylic paint. The red indicates a thrown point and the green a closed. I placed the next layer on top of this piece and you can begin to see the effect that I'm going for here. I glued the track diagram into position, doing my best to make sure that there is no overflow of glue. The glue can be cleaned, but it affects the acrylic, as you'll see later on, because unfortunately I did make 1 or 2 mistakes. With the track diagram in place, I placed the center section in position. I cut some circles out of white acrylic and I engraved numbers in the center. I painted a generous amount of black acrylic paint into the engraved numbers, and when the paint dried, I used a fine grit sanding block to remove the excess paint that was left on the surface of the circle. I have to admit that aligning and gluing these numbers in place was a seriously tedious task. And as is really common with this on-the-fly work, I identified a minor design flaw that I should have actually seen earlier in the process. It would have been better to incorporate an alignment tab into each circle, or alternatively have a flat edge somewhere in order to align each number easily, but in the end it all came together well. So here is the final result with all the numbers in place. I also added some clear pieces of acrylic over the green and red indicators. I was happy for the most part, but after trying to clean up some excess glue with fine grit sandpaper, I actually ended up destroying the gloss finish. Now this might seem like a huge issue, but I've dealt with this type of thing in the past before, so I did have a plan to rectify it. The solution to my problem was to change the gloss finish to a matte finish, and I did this by giving the panel 3 coats of matte lacquer clear coat, allowing each coat to dry fully in direct sunlight. This is the end result, and I was actually far happier with this finish than the gloss finish. And here is the panel with all the toggles installed. I didn't actually notice it at first, but I'd smudged a whole bunch of paint on the back of the backing card. It's no big deal really, because it won't be visible at all. With all the toggles secure, I got stuck into soldering all the cables in place. I used a length of network cable and chose 9 wires for each toggle and the common ground. I fed the network cable through the switchboard housing and the side of the layout, and I secured the switch panel in place with 4 screws. I was very happy with how it turned out, and there was definitely a boost in enthusiasm and motivation when I saw what the switch panel looked like in place. I was careful to ensure that none of the wires got caught on anything, and I also made sure that there was ample clearance for all the toggle switches. You'll notice that there's a 5mm thick piece of acrylic that I used to give me that extra height so the toggles wouldn't catch on anything. With the switch panel in place, I could now turn my attention to connecting the wiring to the Arduino board underneath the layout. Before I mounted the servos and the Arduino board in place, I wanted to make sure that everything worked the way it was supposed to. I connected my network wire up to the Arduino board with one lead from each toggle going to the relevant input pin on the board. I also connected up the common ground wire that ran across all the switches to the ground terminal on the board. I powered up the boards with a 5V 1A power supply, and I proceeded to check each toggle switch to make sure that it ran the point in both directions depending on which way I had the toggle set. This crucial test was completed with no issues, and it was now time to cut out and assemble some servo mounting brackets. I designed these servo brackets some time back, and there's nothing overly special about them, but they do the job really well. If you browse YouTube, you can find many different ways to build servo brackets. Some of them require some type of skill in design and fabrication, and others are as simple as an aluminium channel that the bracket mounts into. I had spare MDF and the laser cutter, so I just did what came naturally to me. The servo is mounted in the bracket with 2 small screws that come with each servo. The point will be physically switched by a rod that is connected to the servo horn. I bent some 1mm wire rod that I got from a hobby store into the correct shape, and I attached it to the servo horn. Next, I feed the wire through the centering hole in the servo bracket, and I finally clip the horn onto the servo. Here is the servo hooked up to the board for a test run, so you can see how this mechanism works. This step really highlights how slowly the switching of the point actually takes place. We can also see the range of motion of the code that I loaded before, and the wonderful thing is that all of this is adjustable for fine tuning. In order to get a good switching of the point, I needed to mount the brackets correctly, and it all starts with locating this small hole in the point. This is where the servo rod will go through and switch the point. Next, I put my servo bracket in place, and I made sure that it is aligned with the point it is going to switch. The brackets run in the same orientation as the point, so that means that the sides of the bracket are parallel to the edge of the track. I use my marker to mark the holes that I need to drill out for mounting the brackets in place. I'm only going to use 2 screws per bracket, and that works perfectly for this application. With the holes drilled out, I replace the bracket and mount it in place, ensuring that it's firmly mounted. I'm going to save you all the tedium of watching me secure 8 servo brackets in place, and just jump ahead to what it looked like when it was all done. Now that all the servo brackets were mounted in place, I could connect all the wiring up to the main board and do some work on neatening it all up. I cable tied wires together where possible, and I used thin PVC trunking to keep wires from interfering with the motion of the servos. The outlying servos got some servo extension cables to help them reach the main board. In the past, I've been a bit of a perfectionist where it really wasn't necessary, and it's so important for me to just keep sight of the fact that this is just allowed to have fun with on a dining room table. So looking at it as it is, I'm pretty happy with the end result, and I really can't wait to flip it over and test everything out. So it's finally time to test these points out, and all the hard work was absolutely worth it. The toggle switches all do what they're supposed to, and the points operate beautifully. There are some servo rods that I still need to trim down a bit, but that's an easy fix. I did notice that a switch blade on the double slip took some damage from the previous layout, but that's also a quick fix. So this week's video took a lot to get done. Each wiring activity was time consuming, and it took time to test each of the combinations that I did. The servos take a little more preparation than the coil motors, but I personally feel that it's worth it, especially on a small layout like this where the points are visible really close up. Again, I want to emphasize how happy I am with this switch panel. I feel that it looks really good, and I think it is a feature to the layout, and it's probably because of its close proximity to the operator. So that's going to be it for today's video. I want to say a huge thank you to everyone that has subscribed so far and that watches these videos. It really means a lot to me. If you haven't already, please like, subscribe, share, and comment. And until next time, go well and keep training.